Good evening. I'm Spot On Weather meteorologist Matthew Euler, and welcome to tonight's special video, Winter Storm Likely. And that winter storm is going to be likely specifically on Friday, the 21st of January, really going from the afternoon on Friday, persisting all the way through the early morning hours on Saturday, the 22nd of January. And here's a nice picture. This occurred actually in Hampton Roads cities. This was a previous snowstorm. I believe this was the December 2010, just after Christmas snowstorm, where Hampton Roads cities received up to 14 inches of snow. And so you see a gentleman here trying to cross the road. The roads are very snow-covered in this particular image. And you can even see those white snowflakes on the streetlight poles down the street there. So I know it's close to Christmas time. And that's what's making me think this is a December 2010 storm. So let's get right into the latest update on the models. And I'll go ahead and conclude tonight's video with my thoughts on what I think will happen. And then before I really jump into these particular slides, I do want to mention this is an extremely tricky forecast. All right. I look back at last week's storm again, and I think to myself, the model's pretty much locked onto that storm and it's tracked right inland up the eastern seaboard up through New England. The models, both the GFS European and then the Canadian, just jumped on board with the track a good solid 5 days in advance of the storm actually occurring, which was quite impressive. But here's the thing with coastal snowstorms, especially for the southern mid-Atlantic and southeastern Virginia. This is the thing, is very important. The forecaster is never easy, all right, because you're dealing with the ocean and the marine influence with these particular storms a lot of times. And so one of the biggest challenges is, where does the rain-snow line set up? And the second challenge is, for coastal storms in particular, what is that storm track going to do? And just a slight difference in the storm track, whether it's 30 miles further offshore to the east or 30 miles closer to the coast, can have huge implications on the sensible weather, to where you might be expecting 6 to 7, maybe even 8 inches of snow, and then you wake up the next morning and the coastal low and the models have shifted the storm 30 to 50 miles to the east offshore further, and next thing you know, you only have 1 to 3 inches of snow. So again, this is a very tricky situation in the forecast, even today. And we're sitting, within 48 hours of this potential winter event. All right, so I'm going to do the model comparisons. We're going to start with the GFS forecast. This is based on the 12Z, the midday model runs for today, the 19th of January 2022. So this is the forecast for tomorrow. Let me get my slide pointers out here. All right. So by tomorrow morning, the chart here on the left is tomorrow morning. Time is 7 a.m. local time, 7 a.m. Eastern time. And we see an Arctic frontal boundary that's extending generally along the East Coast. And we have a 1,046 millibar high that's positioned over Minnesota. And very cold air is basically filtering into the Midwest tomorrow morning. The Arctic front is knocking on the door for southeast Virginia. Not quite reached the coast yet at this point. And we do see some liquid precipitation out ahead of the Arctic front with snow, a changeover to snow behind the Arctic front, extending from Connecticut on down through New Jersey, eastern Pennsylvania, Maryland, into West Virginia, and down over the southwestern portion of the state of Virginia. Now later in the day, the graphic on the right shows the GFS forecast. Later in the day, the Arctic front is making its way through Hampton Roads cities. It's basically just starting to make its way through about 1 p.m. tomorrow afternoon local time. Okay, so we still have some rain showers out ahead of the Arctic front, and then immediately right behind it, it's going to feel like the temperatures are just going to drop out and bottom out basically, as this 1043 millibar high, very strong high situated over Minnesota, funnels in much colder air behind the Arctic front. So we're going to start off with pretty mild temperatures in the morning tomorrow for southeast Virginia. As this Arctic front comes through, we're going to feel much colder temperatures by late afternoon, and eventually we'll see a changeover from rain to snow. Now let's move ahead. Move ahead to the 21st of January. Now this is this Friday, and you'll notice as we head into early morning on Friday, we have an area of snow, possibly a little bit of mix over southeastern Virginia. There is a wave or area of low pressure that's fairly weak that is formed just out ahead of the Arctic boundary, and it's much colder by this point. So low temperatures by Friday morning are going to be dropping into the upper 20s to low 30s pretty much area-wide in southeast Virginia. And again, we may get a little bit of a coating. We might get a little bit of a coating or dusting from this, possibly as much as 1 inch on some of the models. But a couple slick spots, but that's not the major show yet. All right, as we move over here to the right, the GFS forecast, this graphic on the right shows some lingering snow showers right on into still on early Friday morning, the 21st of January. A 1039 millibar strong Arctic high situated over eastern Iowa. Just bone-chilling cold on northeasterly winds from New England right on down into the mid-Atlantic. And then there's going to be another wave of low pressure in the western Gulf. And actually, there's winter weather advisories up tonight for South Texas. Winter storm warnings for ice. And, eventually this energy is going to move along a stalled frontal boundary along the eastern seaboard. Now, moving ahead. This is Friday afternoon on the GFS model. And a little bit of energy is now riding up along this stalled Arctic frontal boundary just offshore, and we're getting some frozen precipitation, some snow from North Carolina on into southeastern Virginia. By early afternoon, we might see a few snow showers or snow flurries in the air, a lot of ice across eastern North Carolina. And then the graphic on the right here shows this is going to be moving ahead now to overnight on Friday night. So this is that secondary area of low pressure that's formed offshore, and you see snow overspreading North Carolina into southeastern Virginia. Okay, a lot of the other precip in the form of rain remains offshore, but you can see we have this area of low pressure. And by the way, the position on the GFS model has trended further southeast and offshore today. Okay. Now let's look at the Canadian forecast model. Now this is also for tomorrow, the 20th of January. On Thursday, the 20th of January, 2022. The Arctic boundary, pretty similar to GFS, situated back to western Virginia in the early morning hours. This is 7 a.m. local time. And we do have a changeover behind the Arctic front to snow in parts of Pennsylvania, West Virginia, eastern Kentucky, southern Ohio, but just showers out ahead of it. By the time we get, according to the Canadian model forecast, by the time we get towards 7 p.m. on Thursday evening, the 20th of January, we start to see that transition to a snow. So the Canadian model is later than the GFS on the transition from rain to snow. All right. Still the similar synoptic setup with these features, these pressure features. We have 1,041 millibar high, Arctic high over Iowa, plenty of cold air on this front side of this high as we have clockwise flow around the high, and then we have the moisture. So we have moisture starting to fall into much colder Arctic dense air, and that's going to be a little bit of snow across southeast Virginia. Now, moving ahead on the Canadian, now we're moving ahead to, this would be early Friday morning. We see a little area of snow there on the northwest side of the precipitation shield, and much colder air. Like I said, temperatures on Friday morning projected to be generally in the upper 20s to low 30s across southeast Virginia. On the right-hand side here, you notice what's happening here. Now we got a wave of low pressure that's formed along the stalled Arctic boundary. This is by Friday night, overnight. This is like 1 a.m. heading into Saturday morning, 1 a.m. Friday night. And you get this little band of snow on the northwest side of this area of low pressure. Okay? So in this case, too, I want to mention that before this shifts offshore, this precipitation shield, we may see snow becoming heavy overnight Friday night across northeast North Carolina and Hampton Roads. Now, moving ahead further now on the Canadian forecast, this is Saturday the 22nd of January 2022, and we see the snow, the backside of the snow, just hanging on across northeast North Carolina and southeastern Virginia. There's the area of low pressure well offshore to the east of the mid-Atlantic coast. And so we're still seeing some residual moisture on the backside of the low. So we're expecting snow to persist through early Saturday morning. And I will get into the snowfall maps here in a little bit. Now let's compare the 12Z 19 January model run of the European forecast. Now the graphic in the upper left is for Thursday afternoon, 20 January, that's tomorrow. Very similar situation. Early afternoon, we see the moisture out ahead of the Arctic frontal boundary with some rain showers into North Carolina and into Virginia. And again, we have much colder air, as denoted by these dashed blue lines, which are thickness values. And the lower these thickness values get, the more dense the atmosphere is between the surface and 500 millibars, or 18,000 feet. And so a more compact layer indicates much colder Arctic air. The graphic in the middle here shows, this would be early Friday morning, still showing some lingering moisture along the North Carolina, southeastern Virginia coastline. And by this point, the Arctic air is really oozing in. The graphic on the right shows this would be, we're moving ahead now to Friday night, Friday evening at, this would be 7 p.m. local time. We have an area of low pressure that has formed along this stalled Arctic frontal boundary. And now that low pressure, even though it's a little bit further southeast on this particular model run for the European, it's still much closer. The European is closer and a little bit more intense than the GFS and Canadian models, and as a result, we're getting some pretty good snow rates. If you look at the bottom graphic here, down the center, I'm showing you the precipitation shield on the backside of that low pressure system offshore, and there's some possible banding of moderate to occasionally heavy snow into far northeastern North Carolina and then far southeastern Virginia, and I'm expecting the heaviest snow to occur from 1 a.m. to 6 a.m. on Saturday morning. All right, so bottom line here is we're still comparing these charts, these different model runs. The GFS, first thing I want to mention about GFS, very inconsistent on its snowfall amounts over the past 2 to 3 days. One run, like for example last night's overnight run, was showing a 10 to 12 inch snowstorm across southeastern Virginia. Then we get to the 060 early morning run, backed off tremendously. Then we looked at the 12Z run, which I'm showing you now, the 12Z, the midday model run graphics. It shows a pretty similar scenario to the early morning run. Okay, and then tonight's 18Z run, which I'm not showing you here, is maybe 2 to 3 inch snow across southeastern Virginia, and that's it. But it's jumping around again in its precipitation amounts. So I'm going to keep an eye on that, really close eye on that tonight and tomorrow. As far as Canadian model, it was pretty consistent for about 2 days with its snow amounts and its storm track. And then as of this morning, the Canadian really reduced its snowfall amounts for southeastern Virginia down to about 7 inches from about 12 inches a couple days ago. And then the European model, this has been the most consistent model as far as forecasting snow amounts for southeastern Virginia and northeast North Carolina. They've been some crazy high amounts in past few model runs of the European, talking on the order of 13 to 16 inches of snow across southeast Virginia and far northeastern North Carolina. Notice today in the 12Z run that those totals have come down a little bit. The forecasted amount for snow has come down a little bit. Okay. Also looked at the 18Z run, the evening run today, and still very similar. About a foot of snow is projected for southeastern Virginia between Friday afternoon and Saturday morning. Now, let's take a look at the GFS, the different upper level features, and look at this analysis. I'm going to take you through the GFS, the Canadian, and the European. And I want to point out the atmosphere is three-dimensional again. So therefore, we cannot just pay attention to these surface low tracks, okay? We have to also pay attention to the upper levels. What's happening at 18,000 feet in the atmosphere, at 500 millibars? These are these little disturbances that are known as shortwave troughs. And usually out ahead of these shortwave troughs, you see this orange coloring. That indicates something known as positive vorticity. Positive vorticity tends to indicate rising or upward vertical motion. And as the air rises, it cools, it condenses, it forms clouds, it forms precipitation. And the stronger these little shortwave troughs are, and the associated vorticity ahead of the axis of the trough, the greater the lifting, the quicker the lifting in the atmosphere from the ground up into the sky, and that tends to lead to more robust precipitation totals. Now, in the wintertime, we look at a couple things. We look at the northern stream trough, the colder trough disturbance or energy, and we look at the southern energy piece associated with the subtropical jet stream. And there's times where these two pieces of energy will actually phase, and they merge together and they create one big massive storm. Looking at the GFS upper level 500 millibar vorticity analysis now, this graphic is for Friday morning, the 21st of January. And again, this is based off the midday 12Z model run from 19 January. So when you wake up tomorrow morning, this might be slightly different. But in general, we're seeing a shortwave trough extending from lower Michigan through northern Illinois into Missouri. And then there's another trough associated with energy in the subtropical jet stream down over Mexico. Now, by the time we get to Friday afternoon, this upper level trough, the shortwave trough, is now starting to move its way east into the Ohio Valley. This other piece of energy is still not attached to this piece. So we have two separate pieces of energy. Bottom left here shows the forecast for, this would be Friday evening, and the vorticity maximum, the positive vorticity in the shortwave trough continues moving east. Out ahead of that axis of the trough, out ahead of this, you're going to get rising air motion. Okay, so by this point, we should see some overspreading moisture from the southwest. Bottom right shows the GFS vorticity forecast and placement of the shortwave troughs at 18,000 feet. And now this trough, the shortwave trough, is getting in closer to the east coast. But notice what's going on here. This piece of energy in the subtropical jet stream is not phasing or connecting with this northern stream energy. This is separate. See this orange color over West Virginia? And see this orange color over Louisiana and East Texas? These are not connected. They are not connected, which means they're not phasing, which means we would expect GFS to show us a weaker storm system, one that tends to be more progressive in nature and one that tends to move straight west to east out to sea. Okay, and that's why the GFS model is backed off on the snow amounts, because you're seeing these two pieces of energy not becoming phased into one. The Canadian model, this forecast is for Friday morning, the 21st of January. A very similar placement. It's a positively tilted shortwave trough across the Midwest. The piece of energy in the subtropical jet back over Mexico, similar to the GFS. Upper right-hand corner here shows 18Z. This is early Friday afternoon, 21 January. And that shortwave trough is now making its move again to the Ohio River Valley, similar to the GFS. This energy remains detached and not connected with this particular northern stream energy. In the bottom left, we see a positively tilted shortwave trough, and it's now approaching Kentucky, Tennessee, a lot of lifting going on out ahead of it. And then by the time we get to, this would be overnight Friday night, you can see the vorticity. It's fairly strong, so you will see some lift out ahead of the trough axis out over southeastern Virginia at this point in time. And the stronger this vorticity gets, the greater the lifting and the heavier the precipitation becomes. But again, there are two pieces of energy. This energy of the subtropical jet is detached from that energy. Looking at the European upper level feature analysis, 500 millibars, 18,000 feet above the ground. Now, a little different color scheme on the European model when we look at the vorticity. When you're looking at the positive values, you can see them here on the legend. Green and yellows and orange and red. Those are the positive vorticity values. Now, if I have a red on here, that's really strong vorticity, okay? Basically, the oranges and the reds are the stronger vorticity. So we got this upper level disturbance at 18,000 feet, the shortwave trough. This particular left-hand graphic is Friday afternoon, the 21st of January. And you can see it's a positively tilted trough extending from northeast to southwest. The middle graphic shows that piece of energy moving eastward. That's now located over eastern Kentucky by a Friday evening, the 21st of January. And out ahead of it, you're getting a lot of rising air motion. See these blue shading here? You're getting rising air motion. You're getting precipitation across North Carolina, South Carolina, and southeast Virginia. And notice this, with the European model, this orange shading here over northern Alabama, and then this other piece of energy down along the Texas Gulf Coast, Louisiana. It's trying to phase together here, okay? You can see these pieces of energy, let's see if I can go back. You can see these pieces of energy are much more detached from each other on the Canadian and the GFS, whereas the European model, you can kind of see it's closer to this main cold core trough. And by this point on Friday evening, the 21st, this would be overnight. This would be going in just after midnight on Friday night. This shortwave trough is becoming more neutral tilt, to where it's more north-south oriented now instead of positive. So that tells me that the strength of this shortwave trough, this mid-level disturbance, is getting stronger. And also the main piece of energy still remains back here, but there's a little bit of connection there, okay? So you got deeper amplitude to the shortwave trough, and on the European model, you have much higher snowfall amounts forecasted for southeast Virginia and northeast North Carolina. Now, let's take a look at some of the mesoscale model forecasts. This has changed. I'm going to be honest with you. I was comparing all the midday model runs today. This was 12Z, the midday model run on 19 January, the 12-kilometer NAM forecast. And initially we had, we're showing you radar reflectivity, what the forecast radar is going to look like. And on these graphics, you see blue is snow and purple is ice, green is rain. And so initially we had snow going, this is the 12Z, 12-kilometer NAM forecast. Snow was going into southeast Virginia early morning on Friday morning. And then we move ahead now to, this is about 10 a.m. mid-morning, still snow. And then we move over here in bottom left to Friday night, still some snow. And then bottom right on Saturday morning, the 22nd of January, the back edge of the snow is wrapping up. And look where the low pressure system is. It's closer to the coast. See how close this low pressure is? This red L is to the mid-Atlantic coast. It's closer. So therefore, this particular model run at midday showed 9 inches of snow for southeast Virginia. Okay. Now, the other midday model runs that I did comparisons on today, as of 12Z 19 January models, this is the GFS model. We're getting the snowfall maps now. This was the GFS model forecast based on the midday model run, and it generally has like 2 to 4 inches of snow across southeastern Virginia. If you look at this particular model, this is a Canadian. This is the Canadian global model, and the midday model run backed off big time from the overnight run last night to just 4 inches of snow forecast for southeastern Virginia. Okay. Now, the European model. This was the midday today, 19 January run for the European model, and it's still showing the most snowfall out of all models. 10 inches in Virginia Beach, 7 inches in Norfolk, 8 inches in Suffolk, and then 12 inches just south of the Virginia line into northeastern North Carolina. So it's still showing a heavy swath. It's very localized heavy swath of snow, but it's still there on the European. In fact, I've checked the 18Z run this evening on the European, and it's still there. It shows 12 inches of snow now instead of 10 for Virginia Beach. All right, if we look at the graphic on the right, I'm showing the UKMET forecast. This was as of the midday model run on 19 January, showing anywhere from 6.7 to 7.5 inches of snow for northeast North Carolina, extending southwestward into northeast North Carolina. Now, some of the more mesoscale model snowfall forecasts. Again, this was the, on the left here, this is the NAM 12 kilometer on a 10-to-1 ratio, showing about 9 inches of snow for Virginia Beach, 6 inches for Suffolk, and then the closer you get to the coast, the more you get. 10 inches down in northeast North Carolina. This was the NAM 12 kilometer higher resolution model. And on the right-hand side here, I'm showing the Canadian resolution, the more mesoscale, higher resolution model over here on the right, the RDPS, showing 7.2 inches for Virginia Beach, 5.6 inches for Chesapeake. So in general, generally 5 to 8 inch snow band across southeastern Virginia on the Canadian regional model. So looking at all these snowfall comparisons, GFS went down big time from last night. They were at over 11 inches last night. And then just comparisons here, very similar in the output for the snow, 2 to 4 inches southeastern Virginia on these two models at midday. And then the European's still the outlier with it's still saying more than that. And then the UKMET is kind of like between the European and the GFS. And then the NAM, which we just took a look at, is about 9 inches for Southeast Virginia, and then about 7 inches on the Canadian regional model. Now, this is the official NOAA forecast. This is the forecast that was issued this afternoon. You can see it right here. January 19th, 2022 at 4:07 p.m. Eastern Standard Time. This was the forecast at 4 p.m. East, just after 4 p.m. Eastern Time today on 19 January. Notice 6 to 8 inches of snow. Norfolk down to Windsor in North Carolina. 4 to 6 inches of snow. Emporia, on to Franklin, Williamsburg. And then as you go back towards the northwest, the snow gets less and less. Only 1 inch at Farmville, 2 inches at Richmond. Okay? So if there's a sweet spot, that has the highest potential for more significant higher snowfall totals, it is going to be right here in southeastern Virginia and northeast North Carolina along the coast. You see this orange shading here? Look at the legend on the left. That's 8 to 12 inches of snow forecast. And this is basically between Thursday 20 January and Saturday 22 January, okay? So this, and when I see these orange colors like this is really something, more mesoscale effects, smaller scale effects that I'm thinking of right now, because we're going to have a strong northerly wind coming down the Chesapeake Bay, and we have 41-degree water. We're going to have much colder Arctic air over that at 5,000 feet in the atmosphere. And so what you get is very unstable air mass, that very cold Arctic wind, that northerly wind blowing over the fetch of the Chesapeake Bay is going to pick up some of the warmth and the moisture from the bay as these strong northerly winds blow. And I look at this, the way this is set up, this to me looks like this could be mesoscale banding potential along the immediate coast, just by the geography and the nature of the snow forecast chart by NOAA. All right, so real interesting. And I will say, someone who wants snow like myself, very discouraging watching the GFS today, very discouraging watching the Canadian model today, because the trend has been for lesser and lesser amounts of snow and a further offshore storm system, okay? But the European is hanging in there. I'm not sure if this is a blend, the National Blend of models the Weather Service is using for this particular forecast for the snow. This is going to change overnight based on the models. I'm going to be curious to see what the overnight run of the European shows. And then whether the GFS kind of comes back to a little bit heavier amounts. All right, so here's my final thoughts for tonight's video. There is a significant winter storm possible for sure for Southeast Virginia, including Hampton Roads cities, between Thursday 20 January and Saturday 22 January 2022. Based off the latest forecast models, which I use the midday models today in 19 January, this video is strictly based off those models. And I've noticed a more southeasterly offshore storm track trend between overnight run last night and this evening's run for the GFS especially. So at this time, based on what I'm seeing, I'm kind of taking a combination of all the models, all these snowfall forecast models, okay? And I'm going with a forecast of 5 to 9 inches of snow for Chesapeake and Virginia Beach. I think the closer you get to the coast, the higher the amount will be, based on the storm track and based on those mesoscale effects, as I mentioned, with strong northerly winds coming down the fetch of the Chesapeake Bay, picking up additional moisture and potential snow band effect. I think towards Chesapeake, especially get towards western parts of Chesapeake, out towards Suffolk, you're probably looking more in the line of 5 to 6 inches. Okay. For Norfolk, I could see about 7 inches, possibly 6 to 7. So that's why I got the 4 to 8 inches there for Norfolk. I expect lighter amounts to the north and northwest. This is one of those storm systems where you're just going to get a very narrow stripe of snow. And we have to watch the model trends too, because if the storm system continues to work its way further and further offshore, the snow total forecast will go down further. Okay, we could wake up tomorrow morning and the storm track on all the models is now 30 to 50 miles further east and offshore, and these numbers right here, 5 to 9 inches of snow, that might become 2 to 4. Okay, so just keep that in mind. This is not set in stone yet. This is just strictly based off what I see in the analysis today. Snow may occasionally be mixed in with sleet or ice pellets as you get closer to the coast, closer to the water. The heaviest snow will fall from Friday evening through the overnight hours. If you get those smaller scale atmospheric processes, look at this bullet here. The most significant winter storms for southeastern Virginia always have smaller scale atmospheric processes associated with these mesoscale precipitation banding features, and that can add to the totals relatively quickly for a very narrow corridor closer to the coast, and that may happen with this storm. Okay, I mean, you get one of those heavier snow mesoscale snow bands over your location, you could be looking at heavy snow for a 1 to 2 hour period, and you might have snowfall rates of 1 to 2 inches per hour. You might accumulate a quick 3 to 4 inches of snow if you get one of those heavier bands setting up over your particular location. All right, and so this is one of those cases where the further northwest you get, you might get next to nothing, like further back towards Richmond. You might only have 1 inch of snow out of this. So if you got in your car and drove from Virginia Beach to even just Williamsburg up to Richmond, there's going to be a drastic difference of the amount of snow that's received at those locations. Additionally, the area closest to the rain snow line is going to see the heaviest amounts, and this occurs in almost every storm I've watched. Wherever you're right there on the transition zone, right on the cold side of it, you're going to get the heaviest snow amounts. And I'm also watching the mesoscale models closely for changing forecast snowfall amounts. These snowfall amounts are not etched in stone. This is a very tricky forecast, as I mentioned. There's just a lot of different dynamics here, and it's really boggling my mind that we don't have 100% agreement in the models right now. GFS, it's like GFS versus European model. Europeans stick into the higher amounts, GFS the lower amounts. Will we have a compromise in the middle, a blend between the two? Possibly. But being that we're only 36 hours out, within 48 at least, this is really surprising that there's still quite a bit of discrepancy in that storm track. Where does that storm track end up? That's going to be the key. So we'll continue to watch the higher resolution mesoscale models for changing forecast snowfall amounts. And again, we could all wake up tomorrow morning and either be, if you like snow, be extremely happy, or wake up tomorrow morning and the snow totals have gone down drastically. The National Weather Service in Wakefield does have a winter storm watch in effect for the area, for southeastern Virginia, Hampton Road cities. It's lasting until Saturday morning. But again, that could be downgraded overnight to a winter weather advisory. I do see that NOAA on their official products is, they're sticking to their guns, man. I mean, look at this. I mean, this is the official forecast from NOAA, and that 6 to 12 inch band or 8 to 12 inch band is just sitting here in this orange shading. I mean, this is impressive. So we're going to have to wait and see. This is the fun part. We try to do our best in forecasting this, but there's always a wild card when you involve with winter storms across the Mid-Atlantic. It's the nature of the beast. But again, I appreciate everybody's subscriptions to the channel. Thank you so much for watching. Keep watching the Facebook and the Twitter social media areas for my updated forecasts. And buckle up, everybody. Hey, at least we got a chance for snow, right? So I want to wish everybody a great evening. Thanks for watching. Thanks for listening. Take care. God bless. Until next time.